Okay, this is 10.3, the double angle and half angle formulas, and we're going to do double angle and half angle formulas for sine, cosine, and tangent today. Our objective, to apply the double angle and half angle formulas, and I think a bigger objective than that is to actually discover them. So, I know you're wondering right now, why do we have all of these extra identities, angle sum, angle difference, double angle, half angle? Well, think about that. When you first started studying trigonometry, you had the unit circle, and you had these key angles on the unit circle, whether they were in degrees or radians, in which you could give exact outputs for sine and cosine, and then use those to get exact outputs for tangent, and then use your reciprocal relationships to get exact outputs for the other three trig functions as well. But you can only do stuff with these key angles on the unit circle. So we're starting to develop the identities that we can get more and more exact answers, because you guys know, when you go into engineering, we don't want approximations, we want exact answers. So when we design things, we're not compromising the structural integrity of whatever it is we're creating. So with that said, let's have a little fun. So let's first review our angle sum formulas for both sine and cosine. All right, so let's see, sine of alpha plus beta. Well, my first term in the first factor in the first term would be a sine of alpha, and then you've got a cosine of beta, and then remember the sign remains the same, so do you see this plus right here? We'll go plus, and then we're going to go cosine of alpha, sine of beta. Okay. Now, remember the title today's lesson. Part of it was double angle formulas. All right, so let's develop a double angle identity. In fact, let's develop several of them today. So it's really easy to do, and this is how mathematicians have done this throughout the ages. You take an identity and you use that to create new needed identities. So all we're going to do here is take this sine of alpha plus beta, and to see the beta, let's make it alpha, because that becomes sine of 2 alpha, and we are developing then a double angle identity, sine of 2 times alpha. So that takes this expression up here, and very simply, the betas now become alphas. And right there, just like that. So now let's simplify. That will imply, and I'm going to write sine of alpha plus alpha as sine of 2 alpha. That equals, and we have sine of alpha, cosine of alpha, plus cosine of alpha, sine of alpha. Now, by the commutative property of multiplication, those are the same terms, so that's going to be nothing more than 2 times sine of alpha, cosine of alpha. And there you go. There's your double angle identity for sine right there. All right, now let's do the same thing for cosine of alpha plus beta. Let's review this little identity that we learned last week. All right, so my first term is going to be cosine of alpha, and then I'm going to have a cosine of beta, but now if this is a plus, this becomes a minus. So in cosine, the functions are the same, but the sign is the opposite sign. And then after this, I'm going to have sine of alpha, sine of beta. And there you go. Now, you know what we're going to do next. We want to make a double angle identity. So we're going to take this cosine of alpha plus beta, and it's going to become cosine of alpha plus alpha, which is, of course, cosine of 2 alpha. So all we're going to do is change the betas up here to alphas. So I have a cosine of alpha times cosine of alpha right there. Now, isn't that cos squared of alpha? Oh, and I didn't skip that step like I thought I would, so I'm just going to do my direct substitution. So cosine of alpha times cosine of not beta, but cosine of alpha, minus, and then sine of alpha times sine of another alpha right there. All right, now let's simplify this. All right, so cosine of alpha plus alpha, I'm going to write as cosine of 2 alpha. And cosine of alpha times cosine of alpha is cos squared alpha, minus And then sine of alpha times sine of alpha is sine squared alpha. All right? And you have your identity now for cosine of 2 alpha. Right there. Now, here's the situation here. Sine of 2 alpha, we only have one identity for. But because of our Pythagorean identities or our Pythagorean relationships, do you see the co-squared and the sine squared here? I can rewrite this in 2 other ways. So there are 3 identities for cosine of 2 alpha. And, you know, in a way, that's kind of a drag because you have 3 identities to memorize. But also, depending on the given information, one identity may be much more convenient than another. So this, I think, is a positive. So what I'm going to do is this. I'm going to say, and again, I'm using my Pythagorean relationship, sine squared of alpha plus cos squared of alpha equals 1, which implies sine squared of alpha equals 1 minus cos squared of alpha, or cos squared of alpha equals 1 minus sine squared of alpha, and we can just do direct substitution with those. So I'm going to say cosine of 2 alpha is, and do you see this cos squared of alpha right here? What if I thought of that as 1 minus sine squared of alpha? So 1 minus sine squared of alpha minus another sine squared of alpha, and that becomes 1 minus 2 sine squared alpha. And there's your second identity right there. Okay, now the third one. Well, this time let's take the sine squared of alpha and substitute 1 minus cos squared of alpha. And be careful with your grouping here. Okay, so what would this simplify to? Well, let's see. I have a cos squared of alpha minus a negative cos squared of alpha. So that's 2 cos squared of alphas minus 1. And those are our 3 identities for cosine of 2 alpha right there. And again, the one I use, you know, it really doesn't matter which one you use. You could use any one of the 3, but depending on the given situation and the given information, one may be more convenient than another. And I honestly find that in my career, my long career in math, I use cosine of 2 alpha equals 1 minus 2 sine squared of alpha more than any of them. All right, and I don't know if it's coincidence or just the way I think. All right, so, hey, guess what? Let's review then tangent of alpha plus beta. Okay, so this is the identity from the other day, the angle sum identity for tangent. So we're going to start with a tangent of alpha plus a tangent of beta, and then our denominator we have a 1 and then a minus, and then you have the product of tangent of alpha and tangent of beta. Tangent of alpha times tangent of beta. Okay, now you know we're going to do exactly the same thing. Let's develop a double angle identity. All right, so what if instead of having alpha plus beta, we had alpha plus alpha, which equals 2 alpha? So tangent of alpha plus alpha, now just direct substitution, the betas in the identity above will now be alphas. So you've got your tangent of alpha plus tangent of alpha is 2 tangent of alpha. And then you have 1 minus tangent of alpha times tangent of alpha, or 1 minus tangent squared alpha. And there's our identity for tangent of 2 alpha, but let's rewrite it in a better form. So I'm going to go tangent of 2 alpha equals 2 tangent of alpha over 1 minus tangent squared of alpha. And we have just developed all of our double angle identities for sine, cosine, and tangent. And remember, cosine has 3 separate identities. Okay. So, what do these problems look like then? Oh, this is great. Look at the given statement. They just say sine of alpha equals 4 over 5, and alpha is in quadrant 1, meaning alpha is an acute angle. And then they want us to find sine of 2 alpha, cosine of 2 alpha, and tangent of 2 alpha. Boy, I hope we have our identities down right there. This will be easy. So, the first thing you want to do is alpha is in quadrant 1. You want to diagram a quadrant 1 right triangle. So there's my acute angle alpha, and I hope you guys are picturing now a right triangle in quadrant 1, and now sine is 4 over 5. Well, SOHCAHTOA, you know sine is opposite to hypotenuse. That would make this leg a 4, and the hypotenuse is a 5. And then I hope you are recognizing a Pythagorean triple right here. Wouldn't this leg have to be a 3? And obviously my triangle is not to scale, but as long as we label everything, we're fine. Now, let's see how many of you already have these memorized. And I know that's not realistic, but we'll practice step by step getting there. All right, so what is the identity for sine of 2 alpha? All right, well, that's going to be 2 sine of alpha, cosine of alpha. How about the identity for cosine of 2 alpha? And you should be thinking right now, well, Mr. Gibbons, there are 3 of them. Which one shall we use? Well, you know what? Remember what I said earlier? Here's an example of that. Didn't they give us sine of alpha is 4 over 5? So how about we use the identity for cosine of 2 alpha that is in terms of sine of alpha? And wouldn't that be 1 minus? I'm simplifying this one first. I was so excited. Okay, we'll come back to that thought in a second. So sine of 2 alpha with this given information right here would be 2, and then sine of alpha, which you can look at the diagram or the given, that's 4/5. And then cosine of alpha, you need your diagram. Cosine is adjacent to hypotenuse, so that'd be a 3/5. And now let's just do our arithmetic. Do you all see a numerator of 8 times 3, 24, and a divisor of 5 times 5, 25? All right, now we can get to this problem right here that I was so excited about. And again, I'm going to use the identity for cosine of 2 alpha that is in terms of sine. So that would be 1 minus 2 sine squared of alpha. Okay, so let's do this one before I jump to tangent. So I've got 1, okay, and then we're going to go minus 2, so I'm taking my time here, 2, okay, and then sine of alpha, but then I have to square it. So again, sine of alpha, I see it here, or in my diagram, that's 4/5. And if I square 4/5, wouldn't that be 16 25ths? And there you go. And now it's just arithmetic again. Now these two terms, I'd want a common denominator of 25. So I am picturing 25 over 25 minus 32 over 25, which will give me a negative 7 over 25. And there's cosine of 2 alpha. Oh, this is fun. Now tangent of 2 alpha equals, now remember, all right, you've got 2, and then what do we have here? You got your tangent of alpha over 1 minus, and what do we have right here? Tangent squared alpha. There you go. Okay, so equals. Okay, so let's go 2. Oh man, I skipped a step there. I'm so sorry. So I'm picturing the 2 times tangent of alpha, and isn't tangent opposite to adjacent? So 2 times 4/3 would be 8/3. All right, I hope I didn't skip a step on this one. Let's go 1 minus. Yeah, I didn't. And then I've got to take that tangent of alpha and square it. So 4/3 squared would be 16/9. Okay, now let me show you a little trick here to save yourself a few steps. See the divisor of 9 and then the divisor of 3? How about we write our numerator with a divisor of 9 to save a step? So I'm thinking 8 over 3 would become 24 over 9. And then this 1 now I'm picturing as a 9 over 9. And 9/9 minus 16/9 would be negative 7/9. Okay, and now because the numerator and the denominator both have a divisor of 9, I can cancel those, and that's going to leave me negative 24/7. Okay, and again, you could have left the negative down below or out front or up top. That doesn't matter. And there you go. That is a great problem right there. And it's just an application of your double angle formulas. Okay, now, look at that. They want us to derive another formula. So derive a formula for sine of 4x in terms of functions of x. Okay, well, let's see. Sine of 4x. Can I use anything we've just done, like maybe a double angle identity for sine? So sine of 4x, could we think of that as sine of 2 times 2x? Look, another double angle. That's 2 times the angle 2x. So now let's use our identity here. And sine of 2 alpha, let's review it. Now isn't that going to be 2 sine of alpha cosine of alpha? There we go. And again, when I'm using these identities, I write them down every time. Equals. All right, so I need my factor of 2 out front. And then in this situation, my alpha is actually 2x. So I'm going to go 2 times sine of alpha becomes 2 times sine of 2x. And then cosine of alpha will become cosine of 2x. All right, well, they said functions of x, and I have functions of 2x, so I'm going to have to use an identity 2 more times. All right, so sine of 2x is right below here, right? So let's start with our 2 again. Times, and what is sine of 2x again? It is 2 sine of x cosine of x. And then what is cosine of 2x? Well, remember my favorite. Cosine of 2 alpha is 1 minus 2 sine squared of alpha. All right, so here I'm going to put 1 minus 2 sine squared of x. And now simplify this, and we are done. So equals, well, 2 times 2 would be 4, so I'm going to start with a 4 sine of x cosine of x right there. And then I still have my 1 minus 2 sine squared of x right there. And now let's just distribute to both terms. So 4 sine of x cosine of x times 1 is 4 sine of x cosine of x. And then I have a minus. Okay, and oh, look at that. I did the 4 times 2. That's the 8 right there. And then you see sine of x times sine squared would be sine cubed of x. And I also have that factor of cosine of x right there. So we have just come up with a, what would we call this? A quadruple angle identity for sine. All right. So I'm going to highlight this because, I don't know, maybe it might come in handy down the road for us. I don't know, maybe in homework or a quiz or, wow, maybe even a test question. Okay, so there you have it. So where are we going to go now? Well, we've handled our double angle identities and we've applied them. So let's hit the half angle formulas. And you know that we're going to have to develop them with the identities we already have. And remember my favorite here? Cosine of 2 alpha is, again, 1 minus 2 sine squared of alpha. All right. Now, how could I use this to come up with a half angle formula? Well, do you see these alphas? What if I decided let's let alpha equal x over 2? That's half of an angle x right there. So let's just do direct substitution, and every alpha becomes x over 2. 1 minus 2 sine squared of alpha, which is also x over 2. Now, let's clean up the left-hand side here. So cosine of 2 times x over 2, the 2's would cancel, and that's just a cosine of x. I like that. Now look at that equation right there. Could we solve for sine of x over 2 and have our half angle identity for sine? I think so. So we're going to solve for sine of x over 2. So let's do a little algebra 1 here. Well, we need to get rid of this 1, so let's subtract 1 from both sides, giving us cosine of x minus 1 on the left. And on the right, we have our negative 2 sine squared of x over 2. All right, well, I don't want that negative, so I'm just going to multiply both sides by negative 1. All right, and if I multiply cosine of x minus 1 by negative 1, don't I get 1 minus cosine of x? All right, good. A little more algebra now. Let's divide both sides by 2. So we have the quantity 1 minus cosine of x divided by 2. and that equals sine squared of x over 2. And now to solve for sine of x over 2, we've got to undo that square with a square root. So we're going to say sine of x over 2 equals, and make sure we talk about the positive and the negative, and then the square root of that entire side. Plus or minus root quantity 1 minus cosine of x divided by 2. Beautiful. We've just done another identity right there. Okay, so let's do the same thing for our half angle identity for cosine. So again, we're going to let alpha equal x over 2. So cosine of 2 alpha becomes cosine of 2 times x over 2. Equals 2 cos squared of alpha is now 2 cos squared of x over 2 and minus 1. And then let's simplify the left-hand side. So cosine of 2 times x over 2 becomes cosine of x, like that. And let's leave the right-hand side alone right now. All right, now let's solve for cosine of x over 2. So we better add 1 to both sides. So I see a 1 plus cosine of x, or you could write that cosine of x plus 1 if you wanted. All right, but let's all do it the same way here. We'll get our answers in the same form that way. All right, and then over here we have 2 cos squared of x over 2. Now let's divide both sides by 2 to get the quantity 1 plus cosine of x over 2. And here the 2's would cancel, and we have cos squared of x over 2. And now the same thing, we have to get rid of that square. So we're going to square root both sides, and when we square root this left-hand side over here, we have to do the positive and negative square root of that entire side. Or plus or minus square root of the quantity 1 plus cosine of x divided by 2. And there is our half angle identity for cosine right there. Okay, wow. Now, how are we going to handle that plus or minus? Well, we'll talk about that in just a second. All right, and do you think now we could possibly use those two identities to come up with a half angle identity for tangent? I'll bet you that's where this is going to go. So first of all, now take a look at these beautiful identities right here. All right, and when I'm applying them, am I going to use the plus or the minus? How am I going to know what to use? Well, when you use the half angle formulas, choose your plus or minus depending on the quadrant in which x over 2 lies. So you just think about this angle right here, all right? Sine of that angle, well, if that angle is in quadrant 1 or quadrant 2, I'm going to be positive. If this angle is in quadrant 3 or quadrant 4, I'm going to be negative. Now over here, cosine, well, if this angle is in quadrant 1 or quadrant 4, cosine would be positive. And if this angle is in quadrant 2 or quadrant 3, cosine would be negative. That's all there is to it. So let's put this in action then. Find the exact value of cosine of 5 pi over 8. Now again, we don't know the exact value because that's not a key angle on our unit circle. But what we do know is we have developed half angle formulas. And isn't 5 pi over 8 equivalent to 5 pi over 4 divided by 2? And I like the angle 5 pi over 4. I hope you do as well. So I'm going to rewrite this as cosine of 5 pi over 4 divided by 2. Now, equals, well, let's think. I know it's this identity, but are we going to do the plus or the minus? All right, so you've got to picture 5 pi over 8 on Leilani's unit circle here. All right, and let me see. Well, 4 pi over 8 would be pi over 2, so isn't 5 pi over 8 going to be slightly into quadrant 2 right there? Oh, I like it. All right, and isn't cosine negative in quadrant 2? So I'm going to use a negative, and then now I got to think to myself, well, let's use our identity. I've got the negative. Here comes my radical with the 1 plus cosine of x, which now the x is 5 pi over 4. All right, let's simplify that. All right, so equals negative radical 1 and cosine of 5 pi over 4. Here's our unit circle, and 5 pi over 4 would be right there. Okay, and isn't cosine of that angle right there in quadrant 3 going to be this horizontal distance of negative root 2 over 2? So let's go 1 minus root 2 over 2. Now, watch the simplification carefully here, because this is not going to get us full credit. It is an exact answer, but it can be simplified. So, there's my negative. Notice how I left the radical in the top for a moment here. Now look, I'm just simplifying the 1 minus root 2 over 2. So I need a common denominator of 2, so that would be 2 minus root 2 over 2. And I'm going to start here under the radical with my 2 minus root 2. And now I'm dividing by 2, but then I'm dividing by 2 again, which is division by 4. So down here would be the square root of 4. And of course, notice the radical isn't down there because the square root of 4 is what? 2. So there is my exact answer right there. Minus radical 2 minus root 2 over 2. And that is an exact answer. If you punch that out on a calculator, the best you're going to get is a decimal approximation. And I kind of have a feeling this is going to be irrational. Okay, so hey, there's our two identities again. Do you think maybe we're going to go tangent now? Why, yes, we are. Look at that. And do you guys agree that tangent of x over 2 would be equivalent to sine of x over 2 over cosine of x over 2? And now let's do our identities directly. Sine of x over 2 is plus or minus this radical. Okay? And cosine of x over 2 is plus or minus this radical. Okay, now, remember when we did the simplifying of trigonometric expressions in the last chapter? This is why right here, okay? So, if I have a plus or a minus over a plus or a minus, isn't that just going to give me a plus or a minus? And then, do you notice that the divisor in my numerator is root 2? And the divisor in my denominator is root 2, so those would cancel, leaving me root 1 minus cosine of x over root 1 plus cosine of x. Now, this looks really good, but again, we simplified trigonometric expressions for moments just like this. I think we can get this even simpler by using the concept of conjugate. All right? So let's simplify. And I did this on another slide, and I apologize, but time was an issue, so I did skip a few steps here, but I will try to verbalize everything so you can clearly see it. So what are we going to do to simplify this? Remember I mentioned conjugates? All right, well, what's the conjugate of 1 minus cosine? That's right, it's 1 plus cosine. And let's just take this term right here and multiply it by root 1 plus cosine of x. And so I don't change anything. I better do the same thing in my denominator. So let's multiply the denominator by the same root 1 plus cosine of x. And now, the reason we're using conjugates is because difference of squares. Do you see a 1 minus cosine times 1 plus cosine under a radical? Well, that'll clean up nice. Equals, now, 1 minus cosine times 1 plus cosine would be 1 minus cos squared of x. And isn't 1 minus cos squared of x sine squared of x? So if I take the square root of sine squared of x, I'm just going to have a sine x in my numerator. I didn't skip that many steps. But so the first thing I have right here is the radical and the 1 minus cosine times 1 plus cosine, I wrote as 1 minus cos squared of x underneath the radical. And then this is just radical times radical, so I squared it. 1 plus cosine times 1 plus cosine underneath the radical. Now, by your Pythagorean relationships, you know 1 minus cos squared of x is sine squared of x, and the square root of sine squared would give me a sine. And then, of course, if I square something underneath a radical, I can just drop the square and the radical. So I have sine of x over 1 plus cosine of x. Okay? And now remember, x will determine my plus or minus, because in my original identity, tangent of x over 2, right? Well, this x is going to determine what's happening here. Okay? So let's do the same thing here now. So this one, now how about we multiply, use the conjugate of our divisor here. So what's the conjugate of 1 plus cosine of x? It is 1 minus cosine of x. So I'm going to multiply my numerator by root 1 minus cosine of x. And I'm going to do that down here as well. And now let's just simplify this, and the same stuff's going to happen. So equals, and up top, all right, I have a radical times itself, meaning I can drop the radical. Okay, and I'm showing that step, so I put it under the radical and I just said 1 minus cosine of x squared. And then do you agree that 1 plus cosine times 1 minus cosine, difference of squares, that's 1 minus cos squared of x, which I love to see that under a radical right there. So clean it up here, and the square dropped the radical, leaving me 1 minus cosine of x. And you guys all know by your Pythagorean relationships, 1 minus cos squared of x is sine squared of x, and the square root of sine squared is sine. And again, the x will determine your plus or minus. So let's go back and finish this off here. So simplify. Okay, well, we did that, and here's what we have right here. Okay, now let's put this in action. Oh man, I don't have an example problem for the tangent. I am so sorry. All right, but here is what I do have. All right, now you've got all of your identities that you have developed today right here. And remember, for the tangent of alpha over 2, you've got to think about the quadrant that your angle is in initially to determine whether these are a plus or a minus. So that's it. You guys, what are the problems we're going to do? Let's do page 383, 1 through 12, 19, 21, and 23. I will post the even answers on in our Google Classroom, and you can check the odd answers in the back of your book and get really, really good at this stuff. If you have questions, you get a hold of me.